In kitchens all over the world, it's waiting in a can, a tube, or a jar. It's the soul of 1,000 sauces, the secret weapon in stews, and the power behind your favorite pizza. It's tomato paste, an ingredient so common we almost take it for granted. But this humble product is a global titan, with a market valued at a staggering $13 billion. So have you ever really stopped to wonder how it's made? How do millions of tons of fresh, sun-ripened tomatoes get transformed into this incredibly dense, rich, and flavorful concentrate? The story is a wild ride, a combination of brilliant farming, clever engineering, and culinary precision. It's a race against time that starts in a sun-drenched field and ends in a marvel of modern food science. Today, we're going on that journey. We're pulling back the curtain on one of the most sophisticated operations in the entire food industry. We'll follow the tomato from the second it's plucked from the vine, through colossal factories, running 24/7, and witness the incredible transformation that turns a delicate fruit into a pantry powerhouse. This isn't just about canning tomatoes. It's a story of science, scale, and the relentless quest to preserve the perfect flavor. This is how tomato paste is made. Chapter 1. The heart of the matter. The processing tomato. Our journey doesn't start with just any old tomato. The juicy heirloom you slice for a salad is worlds away from the one destined for paste. The hero of our story is a special category known as the processing tomato. You won't find these in the produce aisle. For over 60 years, these tomatoes have been bred for one purpose: to be the perfect raw material for paste. Think of them as the workhorses of the tomato world. They have thick, durable skins, and that's not a flaw, it's a feature. It lets them handle the rough and tumble of mechanical harvesting and long truck rides without turning into a pile of mush. Inside, they're even more different. Processing tomatoes are meatier, with less water and more solids. That's the pulp and sugars that give tomato paste its body and taste. This is a huge deal. Since the whole point of making paste is to remove water, starting with a tomato that has less water to begin with makes the entire process way more efficient. Less energy spent on evaporation, more tomatoey goodness captured. They're also bred to ripen all at once. In a field stretching for hundreds of acres, farmers need the whole crop to hit peak red at the same time for a single, massive mechanical harvest. The color is also critical. Processors demand a deep, uniform crimson because that translates directly to the rich red of the final paste, a key sign of quality for all of us. The science here is a constant balancing act. Create a tomato that's tough enough for the journey, packed with solids for efficiency, and bursting with a concentrated flavor that can survive the intense factory process. Chapter 2. The harvest. A race against time. The action begins in vast, sun-baked fields in places with long, hot, dry summers like California, Italy, Spain, and China. Here, tomatoes aren't gently hand-picked. The scale is just too mind-boggling for that. Instead, a fleet of specialized mechanical harvesters rolls through the fields with unbelievable speed. These incredible machines don't just pick the fruit, they swallow the entire plant. Inside, a series of shakers vigorously separates the ripe tomatoes from the vines, spitting the leftover plant matter back onto the field as natural fertilizer for the next crop. As the tomatoes chug along a conveyor belt, they get their first sorting. Powerful fans blow away leaves and twigs. Many harvesters even have electronic sorters that use high-speed cameras to spot and reject green, underripe tomatoes with a quick puff of air, making sure only the best of the best move on. Sometimes, a small crew rides along, doing a final manual check to catch anything the machines missed. The second a tomato is picked, the clock starts ticking. The fruit's natural enzymes start breaking it down. To keep that peak freshness and flavor, the harvested tomatoes have to get to the processing plant fast, usually within just a few hours. The logistics are like a finely tuned ballet. Trucks, each holding about 50,000 pounds of tomatoes, are scheduled to be in the field, ready to be filled. The factories are built right in the middle of the farming zones they serve to cut down travel time. This mad dash from field to factory isn't just a good idea, it's a non-negotiable rule for making top-quality paste. Any delay can mess with everything from its thickness to its taste. Chapter 3. Arrival and Intake. The Mountain of Red. When the massive trucks roll into the factory, they pull onto huge scales to be weighed. But this stop is about more than just quantity. It's about quality. A probe dives into the load, pulling out samples from different spots. These samples are rushed to an on-site lab for a quick but crucial analysis. Technicians run a few key tests that decide the fate and the price of the entire truckload. The most important is the Brix level. Brix is just a fancy word for the amount of natural sugars and solids in the tomato. A higher Brix means a sweeter, more solid tomato, which is perfect for making paste. The lab also checks the color to make sure it's that deep red standard, and the acidity, or pH, which affects both flavor and preservation. The results tell the factory what to pay the farmer and how to route this specific batch for processing. Once the load gets the green light, the unloading begins, and it's a process designed to be both fast and surprisingly gentle. Instead of just dumping the tomatoes, a powerful torrent of water is shot into the trailer. This creates a water flume that carefully floats the tomatoes out and into receiving channels. This flume system does two jobs at once. It moves the fruit without crushing it, and it gives them a good pre-wash, rinsing away dirt and field debris. The site is something else. A literal river of red flowing into the factory, forming a mountain of tomatoes. From here on out, those tomatoes will be in constant motion. Chapter 4. The Great Wash and Sort. After being floated out of the trucks, the tomatoes start a serious cleaning and sorting gauntlet. The flume system got rid of the big stuff, but now it's time for a deep clean. The tomatoes are conveyed into bubble washing tanks where air is pumped into the water, creating a turbulent, jacuzzi-like effect. This gentle agitation shakes loose any stubborn dirt or pesticides. After their bath, the tomatoes hit the sorting lines. This is one of the most vital quality control steps. First, they often move along a manual sorting conveyor. Here, trained workers scan the fast-moving river of red. Their hands a blur as they pull out any defects the machines might have missed. Green. Tomatoes, sun-scorched spots, or stray vines. But at this scale, human eyes can only do so much. The real magic happens at the automated optical sorter. As tomatoes spread out into a single layer on a high-speed belt, they pass under an array of cameras and lasers. In a split second, these sensors scan every single tomato, checking it against a pre-programmed ideal for color and quality. If a sensor spots a bad tomato, say one that's green or has a blemish, the computer instantly calculates its position. A moment later, as the rejected tomato passes a bank of air jets, a targeted puff of compressed air knocks it right off the line. This all happens at blinding speed, allowing factories to sort tons of tomatoes per hour with a consistency humans could never match. This obsession with sorting ensures that only the absolute best, ripest tomatoes make it to the next stage, guaranteeing the final paste will taste great, look vibrant, and last a long time. Chapter 5. The break, hot vs cold. Once the tomatoes are perfectly sorted, it's time to crush them. This stage is called the break, and it's where a crucial scientific choice is made that will define the final paste. The goal is to chop the tomatoes into a pulp while using heat to instantly shut down certain natural enzymes. The main enzyme they're trying to stop is called pectinase. Pectin is what naturally thickens tomato paste. But pectinase acts like a pair of molecular scissors, chopping up the pectin and turning what should be a thick paste into a watery mess. Stop the enzyme, and you get a thick, rich product. There are two ways to do it, and the choice creates two very different products: hot break and cold break. In the hot breaker process, the chopped tomatoes are immediately blasted with high heat, usually between 185 and 212 degrees Fahrenheit, 85 to 100 °C. This intense heat instantly deactivates the enzymes, preserving almost all of the natural pectin. The result is a pulp that will become an incredibly thick and viscous paste. Hot break paste is perfect for things like ketchup or heavy pizza sauce, where you need a thick consistency that won't get watery. The trade-off: the high heat cooks the flavor a bit more. In the hot cold break sonata process, they take a gentler approach. The pulp is heated to a much lower temperature, around 150 to 170 degrees Fahrenheit, 65 to 75 degrees Celsius. At this lower temp, the enzymes get a little bit of time to work before they're deactivated, so some of the pectin breaks down. This results in a paste that's thinner. The big win for cold break is flavor and color. The gentler heat preserves the fresh, bright, natural tomato taste, making it ideal for high-quality pastes that are sold for making gourmet sauces and soups. This choice isn't random. It's a deliberate decision by the manufacturer to create a specific product, showing how one simple step can define the texture and taste of the food on our tables. Chapter 6. Pulping and Refining. The separation. After the break, we have a hot, thick slurry that contains everything: the valuable juice and pulp, but also the skins, seeds, and any leftover bits of stem. The next step is to separate the good from the unwanted, refining that coarse slurry into a perfectly smooth liquid. This is the job of the pulper and finisher machines. The slurry is pumped into the pulper, which is basically a big cylindrical sieve. Inside, rotating paddles press the slurry against a screen with fairly large holes. The juice and fine pulp pass through, while the bigger stuff like seeds and skins are held back. From there, the good stuff moves to the finisher, which works the same way but has a much finer screen. This second stage removes even the tiniest remaining particles, ensuring the final liquid is exceptionally smooth. But what about all the stuff left behind? This mix of skin and seeds, called tomato pomates, is anything but waste. In the spirit of waste not, want not, modern factories see it as a valuable co-product. The pomace is collected, dried, and can be added to animal feed as a nutritious supplement. It's also a concentrated source of lycopene, the antioxidant that makes tomatoes red, which can be extracted for use in supplements and natural food colorings. This commitment to upcycling means that nearly 100% of the original tomato is put to good use. Chapter 7. The Evaporator. Creating the concentrate. What we have now is a smooth, refined tomato juice. It has all the flavor and color, but it's still about 95% water. To turn this into paste, the water has to go. The challenge is doing this without boiling away the flavor or burning the sugars. Just heating it in an open pot would create a dark, bitter mess. The solution is a brilliant piece of engineering: the vacuum evaporator. The science is simple but genius. Water boils at a much lower temperature in a vacuum. By reducing the pressure inside the evaporator, the juice can be brought to a boil at temperatures as low as 150 degrees, 65 degrees Celsius. This gentle heat is the secret to preserving the fresh flavor, bright red color, and nutritional value of the tomatoes. Modern factories use a multi-effect evaporator to be extra efficient. It's a series of connected chambers, each at a lower pressure and temperature than the one before it. The tomato juice is pumped into the first, hottest chamber. The steam that boils off isn't wasted. It's piped over to heat the second chamber, which boils at a lower temperature. The steam from the second heats the third, and so on. This cascading system is incredibly energy efficient. As the thickening juice moves from one chamber to the next, more and more water is removed, and you can see it transform from a thin liquid into a rich, thick paste. The whole process is controlled by sensors that monitor the concentration or Brix level. For double concentrate paste, the target is 28–30% solids. For the richer triple concentrate, it's 36 to 38%. The time it leaves the evaporator, it is unmistakably tomato paste, concentrated not just in flavor, but in volume, saving enormous amounts of space for storage and shipping. Chapter 8. The final hurdle: sterilization and aseptic packaging. The paste that emerges from the evaporator is thick and rich, but it's not ready for your pantry just yet. To make sure it's safe and can last for years without refrigeration, it needs one last critical step: sterilization. The goal is to kill any microorganisms without ruining the taste. The solution is called flash pasteurization, or high temperature, short time HTST sterilization. The paste is pumped through a tube-in-tube system where it's heated to a very high temperature for just a few seconds, then rapidly cooled back down. This quick blast of heat is enough to make the product sterile while minimizing damage to its quality. After sterilization comes packaging. For a long time, this meant canning, but today, the gold standard is aseptic packaging. The word aseptic means free from contamination. In this process, the tomato paste and the package are sterilized separately and then combined inside a totally sterile environment. Here's how it works. The sterile paste is held in a sterile tank. The packaging, often massive multi-layered bags, is also sterilized. Then, inside a sterile filling chamber, the paste flows into the sterile bag, which is then sealed without ever touching outside air. The huge advantage is that the paste doesn't need to be cooked again in its container, which preserves a much fresher flavor and brighter color. Most of the world's tomato paste is first packed this way into huge 55-gallon drums or 1-ton bins, which can be stored for up to 2 years without refrigeration. This allows factories to run non-stop during the short harvest season and then repackage the paste into smaller containers all year round. Chapter 9. The final package, from factory to pantry. The journey is almost over, but the paste still needs to get from those giant aseptic bins into the cans, tubes, and jars we see at the store. This happens on a separate packaging line that can run year-round. The huge bags are opened in a sterile environment, and the paste is pumped into machines that feed the consumer packaging lines. These lines are a dizzying blur of automation. For cans, empty sterilized cans zip along a conveyor, get a precise amount of paste shot into them by pistons, and are then instantly sealed airtight. For tubes, paste is injected into the bottom before the end is crimped shut. For glass jars, a vacuum sealer applies the lid, creating that satisfying pop you hear when you open it for the first time. A sign the seal was perfect. After filling, the containers are rinsed, dried, and sent to a labeling machine that wraps them in their familiar artwork. All along the way, quality control is relentless. Check weighers reject any package that's slightly off, and scanners inspect the seals. Finally, the finished products are bundled into cases, stacked on pallets by robots, and shipped out to find their way to your kitchen. The long journey from a seed in the ground to a staple in the pantry is complete. Chapter 10. The Science of Flavor. Why we love it. Now that our paste is sealed and ready, let's talk about why it's such a culinary powerhouse. Its magic is about more than just tomato flavor. The transformation from fresh tomato to paste creates a chemical profile that chefs depend on to build deep, complex flavors. First, tomato paste is a concentrated source of umami. The fifth basic taste, that savory, meaty flavor you get from aged cheese or soy sauce. Tomatoes are naturally rich in glutamates, and concentrating them concentrates the umami. Adding a spoonful is a shortcut to adding a depth of flavor that would otherwise take hours of simmering. But the real secret weapon of tomato paste is unlocked in your kitchen with one simple step: heat. Many recipes tell you to brown the tomato paste in oil with onions and garlic. And trust me, this isn't just a fussy chef thing. It's a critical chemical reaction. When you heat the paste in oil, its natural sugars and amino acids undergo the Maillard reaction. This is the same reaction that gives you the browned crust on bread or the sear on a steak. By frying the paste, you are completely changing its flavor. The sugars caramelize, mellowing the acidity and adding sweetness. At the same time, the Maillard reaction creates hundreds of new complex roasted and savory notes that just aren't there in the raw paste. This one step transforms the paste from a simple ingredient into the foundational backbone of an entire recipe. From a single seed bred for strength and flavor to a fruit harvested in a frantic race against time, through a torrent of water and light sorted by human and machine. Broken down, transformed by heat and pressure, its very essence captured by brilliant engineering, sterilized, sealed, and ready for a journey to kitchens everywhere. The story of tomato paste is a quiet triumph of human ingenuity. It's a process that weaves together farming, mechanics, and chemistry to capture the fleeting taste of summer in a form we can enjoy any day of the year. So the next time you pop open a can, take a second to appreciate the incredible, unseen journey inside. It's the story of how a simple tomato becomes the rich foundation for countless meals and memories. If you found this journey into the world of food fascinating, be sure to like this video, share it with a friend who loves to cook, and subscribe for more behind-the-scenes looks at how your food is made. We'd love to hear from you, so let us know in the comments what everyday ingredient we should explore next.